Welcome everyone to a new Godot tutorial. Today I'm going to showcase the basics of how I made the grass in my terrain editor. First, sorry for the lack of updates. I've got a busier time than usual at my day job. I am currently working on a shader tutorial together with another YouTuber, and that will likely be my next video. I also plan to do an update video soon. I've prepared a scene already where I have applied a height map to a plane. We'll be adding grass to this terrain. Your normal starting point would be to simply create a mesh instance. I'm starting there as well, but only because it makes it easy to set up a few things. I've created a mesh in Blender, which is made up of 3 textured planes organized in an overlapping triangle. As I move the camera around, you can see that we can't see all 3 sides all the time. This is because by default Godot only renders one side of a face, as the other side is often hidden inside of an object. We're going to add a spatial material to our mesh instance and change a few settings. First, we're going to disable the cull mode. This will result in both sides of the faces being rendered. Now when I rotate my camera, you can see that it looks as it should. Now we need to apply textures to our object. I found a nice grass texture pack made by Nobiax on OpenGameArt. I've put the link down below. We have both a diffuse color texture and a normal map that we'll use. Now we do see a couple of problems right away as we move our camera around. First, let's get rid of that shininess by turning up the roughness setting on our material. Next, we'll turn on alpha scissor. This will result in the alpha channel of our texture being evaluated, and when it drops below the given value, we won't be drawing anything on screen. Alternatively, we could make our material transparent, but that results in draw issues with overlapping grass. Now that looks pretty good. We now only have our blades of grass showing. This, however, is just 3 bits of grass. If we want to fill our entire terrain with grass, we could just create hundreds of copies. Besides it being a lot of work placing them all, it will also start eating into your frame rate. You can deal with the performance issues by using a multi-mesh, and you could deal with the placement issues with some nifty editor tools or some random logic to start off placing your objects. But I'm going to show a different solution. We'll save our material as a resource on disk. We'll be reusing this in a minute. Now we will add a particle system to our scene. Now that may seem a little strange. A particle system is normally used to animate moving large amounts of objects around the screen. But it's a large amount of objects a particle system can place which is interesting to us. It doesn't need to animate things. It can just as easily be used to quickly place tens of thousands of blades of grass. To configure our particle system, we need to change a few things. We'll leave the lifetime of our particles alone, but we'll change the explosiveness to 1. This means all our particles will be created at the same time. I'll move the emitter up for a minute just so we can see it more easily. Note that we'll be adjusting the bounding box later on. Now we need to create a shader material as our process material. We are not going to use a standard particles material, as we'll be implementing our own logic. And as always, we will save this material to a resource file so we can access it more easily and reuse it later on if we wish. Our shader material needs a shader, so we will create that next. And we will save that to disk also. I'll quickly define our shader as a particle shader, but we have a little more setup to do before we write our shader logic. So select our particle emitter again and look up draw passes. Here we define what should be rendered for each particle. We simply select our grass mesh as the particle to be rendered in the first and only draw pass. Now we can see our mesh appear at our particle emitter. All particles being emitted are all drawn in the same location, as we haven't written any logic yet. Now we can access our Geometry tab and we load the grass material we created earlier in the tutorial. we can immediately see our particle being rendered correctly. It is time to write our shader. I'll start with defining a uniform for the number of rows of grass I have. I'm just setting this to 4 to start with, but we'll be increasing this later on. We then define a second uniform that defines the average spacing between our grass particles. We'll default that to 1 unit for now. We'll be writing a vertex shader function. This function is called for every particle that has been emitted. We start by defining a position and setting it to 0. We'll use a built-in variable called index. This variable tells us which particle we are positioning. By taking the modulus of this variable, we can evenly distribute our particles into the number of rows we've configured. I'll add a few comments in. I really should do this from the start. The next thing we'll add is 2 lines of code that centers our grass. And then we will apply our spacing by simply multiplying our position. We don't see any changes on screen because we've not output anything from our vertex function. The built-in transform called transform allows us to orientate and position our particle. We're just going to position it with the position we have so far. Let me quickly change the number of particles to 16. And now we can see 4 nice rows of 4 particles of grass floating in the sky. The next thing we are going to do is turn off the setting local chords. Right now our grass is placed in relation to our emitter, but the moment I turn this setting off, our shader starts using global coordinates and our grass disappears. We still have our little test grass, but we need to turn our terrain off in order to see that our grass has disappeared all the way down into the ground. I do this because I want to start aligning our grass with our camera's position and need finite control over the absolute positioning of the grass. This allows us to move around the terrain and have our grass render all around us regardless of where we are. We will first enhance our logic so our grass is rendered at the correct height. We do this by adding a uniform at the top of our script so we can use our height map in the shader. We also add uniforms to define our amplitude and the size of our height map. We add a function to our shader that samples our height map and returns the height we want to use. We will give this a 2D position that will be populated by our global x and z coordinate. We adjust this so our 0,0 world position is in the center of our height map and then divide by the size of our height map to get uniform coordinates. This will make sure that 1 pixel in our height map equals 1 square unit in our world. Finally, we just take the red channel from our height map and multiply this by our amplitude. This is the same function as we have in the vertex shader of our terrain. Before we continue, we need to load in our height map. We select our particle node, find our process material, and edit it. Then we select the same height map texture as we are using for our terrain. Now we can go back to editing our particle shader and simply add a line of code that calls our height function and assigns the y component of our position. And there we go. Our grass is now properly positioned on the surface of our terrain. However, when we move our emitter around, because we turned local coordinates off, our grass stays put. While I don't want the grass to follow exactly because that would look really weird, grass does not travel, we do want to use our emitter's position to some extent. This will allow us to place our emitter in relation to our camera's position. It also means we can implement a proper bounding box, which we will handle in a bit. We are going to use a built-in variable called emission transform. The third row of this transmission is the position of the emitter and will use its x and z coordinate and subtract the modulus of our spacing. This ensures a uniform grid based on our spacing, and we will always end up with the same base coordinates for a particle at a certain point on our terrain. Now when we move our emitter around, we can see that we render the grass around our emitter. As we move, our 16 particles take on the role of different grass strands on our terrain. The ones further from our emitter seem to disappear, and new ones appear along the path of movement. Note also how they correctly follow the height of the terrain. We're showing this on a small scale now, but as we cover a larger area of the terrain with grass, we see the makings of a shader that extends our entire map, as we automatically render the grass closest to the camera. We select our particle node and create a new script for this. We'll start with a little bit of setup in our script, so we can reuse this and customize it. The first thing we add is an export variable for our rows with a setter and a getter function. We'll add some boilerplate code first, to just set and get our variable. We need to copy the value of our rows variable into our shader. The first time the setter gets called, as the scene is loaded, our material hasn't been set up yet. So we need to check if we have a material, and only if we have it, assign our shader parameter. Note that I'm using the wrong material here. We will correct that in a minute. We also update the amount of particles we will be emitting by taking the square of our rows. Once our ready function executes, our material will be available, so we simply reassign our rows. Now bear with me as I do exactly the same for our spacing variable, including using the wrong material and a nice typo that I will correct in a minute. I just didn't want to re-record everything. It is okay to make mistakes. Whenever our rows or our spacing changes, this affects the area in which we draw our grass. We need to make sure that our emitter's bounding box encompasses the area in which we draw our grass. So we add a function that we call from both setters to adjust the bounding box. Note that I'm fixing the Y component and I'm choosing a value slightly higher than our terrain's amplitude. We will use our process function to align our emitter with our camera. We'll get our viewport and then get our active camera. After that, we assign our camera's global position to our emitter's global position. Now we quickly fix up our two mistakes. We should use our process material and correctly write setShaderParam. Running our project, we see that our grass is now centered on our camera, but there isn't enough to really show anything. We need to correct a small mistake. We have to make sure our emitter is always at Y set to 0. We'll set our rows to 300, which means we'll end up with 90,000 grass objects. I've set this much higher in trials, but this is a good number for our demo. However, we won't see this applied until we run our game. Now that is a lot of grass. We can see that our grass covers our entire terrain. As we move our camera, it seems the grass goes on, even after we reach the end of our terrain. Because our height map is a tileable texture, we see its effects repeated as well. Our grass, of course, does not go on forever, but because we keep repositioning our emitter, we have created that illusion. With a spacing of 1.0, we see a lot of space between the grass, but I am doing that on purpose because it highlights some of our other problems. Our grass looks very uniform as it is neatly laid out on our grid, so let's tackle that next. Back in our shader, we add a new uniform so we can load in a noise texture. We then assign this texture. This is nothing more than a texture with a bunch of pixels with random color values, and it is a nice cheap way to get some semi-random logic into our shader. Now it is very important that we use our global position as our input for our noise texture lookup, so we get the same noise value for that grass object each and every time. We do apply a scale for this lookup. We then use the red channel to offset our X position and the green channel to offset our Z position. This already gives a much nicer distribution of our grass. It no longer looks uniform. Now there are better noise functions that give a better result, but this was a noise texture I quickly grabbed off the internet. We can use noise for two more changes that make things even better. We'll do one of them next, which is rotating our grass object so they aren't all facing the same way. The other enhancement would be to adjust the scale of our objects, but I'll leave that to you to figure out. I do this in my terrain editor. We are going to use our green channel to determine our rotation. Note that we can interchange RGB and XYZ freely on Vec3 variables. We use a simple cosine and sine rotation that we directly apply onto our transform. We'll also multiply our noise value by 3 so we can have a near full rotation. Now our grass is all pointing into a different direction. However, there is still grass everywhere. Now in my terrain editor, I'm using a separate map to determine where to draw grass and where not to. you can draw into this map to place grass. For our demonstration here, we're going to use a simpler approach just to demonstrate the technique. Instead of reading from a map, we're simply going to check the angle of the slope in both the x and z direction, and if it's larger than a certain value, we do not draw our grass. For this, we need to sample our height map in 2 more places. Now we don't have an output to hide or skip particles, so we're going to cheat. We are simply going to place our grass so low that it will be culled before anything is drawn. As you can see, the grass is now only drawn where our terrain is flat, but not on the side of our mountains. Just to finish off, this is our terrain, but now with the grass shader updated with the version from my terrain editor, so the grass nicely waves with the wind. I've also increased the spacing to create the illusion of really thick grass. This has affected the draw distance, though I could have increased the number of rows, I guess. There is a lot of room for improvement here. Seeing we're centering the grass on our camera, half of our grass is drawn behind our camera. This gets culled pretty quickly, but it is still wasteful. We could determine the angle of the camera combined with the height we are above the ground to move our emitter forward. Note as I zoom out of the scene, you can really see how much grass is being drawn and see how it repositions on the camera. Looking from high up, straight down does break the illusion, as it becomes very clear we're rendering flat planes. You see the same thing in many games that use similar techniques. Well, that's all I have time for today. I hope you enjoyed this video. If so, please give it a like and subscribe to my channel. Also, follow me on Twitter. I often post updates on what I am working on or short clips of effects I'm trying out, so you get a bit of a preview of what is going on. Well, see you next time.